So hello and welcome to our third lecture on naming chemical compounds, that is the nomenclature of naming compounds. We've already talked about the molecular compounds, and we were working our way through the rules for naming ionic compounds. What would be the correct name for this compound? It consists of potassium ions and oxide ions, and therefore it would in fact simply be potassium oxide. What would the formula for magnesium nitride be? Magnesium nitride consists of magnesium ions and nitride ions. The magnesium's a plus through, the nitrate's minus 3, so we have to have enough ions to balance all the charges. And the first number that includes both 2 and 3 is 6. So to form the compound, we're going to need 3 magnesiums for our plus 6 and 2 nitrides for our minus 6 to form the compound. Who would this compound be? Well, it includes cobalt ions and bromides. So, cobalt bromide. But of course that is incorrect because it is insufficient. The cobalt is one of the transition metals, and it has more than one oxidation state. So it's not enough just to say cobalt bromide. We actually have to indicate the charge on the cobalt. That compound is correctly, therefore, cobalt-2 bromide. Now we'll come to a somewhat different problem. What compound do you get if you combine those 3 ions together? K is, of course, potassium, H is hydrogen, PO4 is what is known as a complex ion, and it's known as phosphate. So potassium, hydrogen, phosphate. Well, no, it can't be potassium, hydrogen, phosphate, because potassium, hydrogen, phosphate would have a minus charge on it. Potassium's only a plus 1, the hydrogen's only a plus 1, phosphate's a minus 3. So having just 2 cations isn't enough. We need 3 cations to balance it out. We could come up with 3 cations by either using 1 potassium and 2 hydrogens, or we could use 2 potassiums and 1 hydrogen. And the compound would therefore be potassium hydrogen phosphate. The problem is both those compounds can't be potassium hydrogen phosphate because they are clearly different compounds. They contain different amounts of the elements. And so those names are insufficient. So now what? Well, we can't do anything about the charges on either the cations or the phosphate. They are what they are. We have to balance the charges, and the only thing that's different between those 2 compounds is, in fact, the number of ions we have present. And so we're stuck. We have our third rule for the systematic nomenclature of ionic compounds. You use the Greek prefixes, but only when you are forced to do so, when there is no alternative way of correctly indicating the compound. So the prefix for 1 is mono, the prefix for di is 2, so the top one would be monopotassium dihydrogen phosphate, and the bottom one would be dipotassium monohydrogen phosphate. Often when you have exactly one of the first element, people tend to leave the first mono off. So you would see the top one most often as just potassium dihydrogen phosphate. The second one is also correctly dipotassium monohydrogen phosphate. But you can get by without the monos in those cases, but technically they should be there. This brings us to complex ions. We run into a lot of complex ions, and many of them have a very simple form. That is, they are some element with some number of oxygens, and the whole thing's an anion. And we have rules for naming this kind of a complex ion. And so, to start out with, you simply list the element that is not oxygen to begin with. And so for those 8 complex ions, you'd start out with the element that isn't oxygen. So for the first 2, we'd start out with nitrogen. For the next 2, we'd start out with sulfur. For the next 2, we'd start out with phosphorus. And for the last 2, we'd start out with chlorine. We then change the ending on the element that isn't oxygen to either ITE or ATE, depending on how many oxygens are present. The anion with fewer oxygens gets the ITE ending. The anion with the more oxygen gets the ATE ending. So, for our 4 cases, the ones on the top, which have the fewer of the 2 oxygens, get the ITE ending. And the ones on the bottom with more oxygen get the ATE ending. And so the first 2 are nitrite and nitrate. The next 2 are sulfite and sulfate. Then phosphite and phosphate. And then 2 chlorite and chlorate. For the first 3, that's fine. The problem is for the 4th one, for chlorine, there aren't just 2 possibilities, there are 4 possibilities. We can make 4 different ions that include chlorine and oxygen. The top 2 both have fewer oxygens, so they'd both be chlorite. The bottom 2 both have more oxygen, so they would be chlorate. But they can't both be chlorite and they can't both be chlorate. Well, we've already changed the ending, so to distinguish between the 2, we're going to have to do something else. We're going to have to use a prefix. And we use 2 prefixes. Hypo means even less oxygen, per means even more oxygen. So the first 2 are both chlorite, but one has fewer oxygens, so it gets the prefix and becomes hypochlorite. And of the other 2, the chlorates, the one at the bottom has more chlorate, so it gets the per prefix. And so the 4 complex ions of chlorine and oxygen are hypochlorite, chlorite, chlorate, and perchlorate. But at this point we have kind of a problem. And the problem is, as we said before, you have to know the charge on the complex ions. And what's the charge on the complex ions? Well, that depends on what the ion is. Sometimes the complex ions are -1, sometimes they're -2, sometimes they're -3. And this is a problem with the nomenclature. It doesn't tell you what the charge is. It simply tells you the whole thing's an anion. You have to learn what the charge is. We have a second problem too. More and less. And more and less means what? Well, ITE means 2, unless it means 3 or 1. ATE means 3, unless it means 4. And this is another problem with the nomenclature. It's only semi-systematic. It only tells you more or less what you want to know, but it doesn't tell you exactly what you want to know. And so this is something you're going to just have to learn. You're going to have to learn not just the names, but the formulas and the charges that are present on each of the complex ions. It's not enough just to know that it's phosphorus and oxygen. You got to know how many oxygens, and you got to know what the charge on them are. And we have one more problem you have to worry about. We also have this non-complex ions, nitride. And why is that a problem? Well, what's the difference between nitrate, nitrite, and nitride? It's those two letters. Everything else about those names are the same, just those two letters, and they overlap each other. And this is a problem, because those three materials are utterly different materials. One of those ions is very stable. One of those ions is sort of reactive, and one of those ions is an explosive. They have three totally different set of properties, and the only difference between those names is those two letters, and those two letters overlap. And this is something that is vital at this point in learning the nomenclature. You have to get those names really correct. It's nitrite, it's nitrate, it's nitride. In pronouncing the names, you have to be distinctive. And even more so, in writing the formulas out, you have to make sure you're spelling them exactly right. This is a case where getting it close isn't a minor technical mistake. It's a catastrophe waiting to happen. If you go into the stockroom and get potassium nitro something or other, you're going to have a really short career. It is important in getting the spelling right, getting the formula right, getting the charge on them right. You're going to have to spend all your time studying nomenclature, learning the names that go with the complex ions. And that concludes today's lecture on the ionic compounds. Go have a nice day.